Hello, Bree. Hello, everyone. Good morning, good evening, good afternoon, wherever you are joining us from in the world. And we have folks from all over, which is so exciting. Thank you so much for hanging out with us here today. My name is Jamie Singleton. I'm a senior program manager on the .NET community team, and I am joined with my good friend and colleague, Bree Ackman.
Hey, everyone.
So today, it is fall season here. I am located in New York City. It is fall. It is also Halloween season for those of us who celebrate. I certainly do. So I'm feeling very festive. But we have a lot to talk about today that is not Halloween or fall related. We are going to be talking about machine learning, and specifically machine learning with .NET. So Bree, can you tell us a little bit about that? What is machine learning? Why is it important? And why do we need it?
Yeah, well, I guess I should have first told you all like why I'm even somewhat qualified to talk about this. So I'm also a PM on the .NET team. I work on ML.NET, which is machine learning for .NET. And yeah, I actually have. Do you want me to get into the slides to start digging into what is machine learning? Because I have a lot of information for everyone. So
Yeah, sure. Let's pull up your slides and dig right in.
yeah. So it's funny that you mentioned that it's Halloween this weekend for those of us that celebrate. And machine learning does sound very spooky to a lot of people. So I feel like it's very fitting because it is like it's a lot of people feel like it's very scary or intimidating, but it's really not. And I hope that today we can show you that it really is. It can be easy, especially with ML.NET. But that's my quick plug. So yeah, let us get into it. We'll go through slides and then we'll show you a really awesome demo, obviously, that you can follow along with the MS Learn module. So first thing is, what is machine learning? Well, there's a few concepts that we want to grasp here. First is artificial intelligence. So artificial intelligence is the ability of a computer to do tasks that are usually associated with intelligent beings or humans. So this could be things like reasoning, discovering meaning, learning from past experience, and so on. So that's kind of the big area of artificial intelligence. So you might think of like a chat bot that you, or a virtual assistant when you go onto a website for customer support and you're not talking to a human, but one of those virtual assistants. That's usually artificial intelligence. So within that, we've got a subset within artificial intelligence called machine learning. So that's what we're going to focus on today. So it's a type of artificial intelligence, but this is getting computers to make predictions without being explicitly programmed. And I'll get into more of what this means in a second. So within machine learning, you also have deep learning. So deep learning is a subset of machine learning. And of course, that means it's a subset of artificial intelligence. But the deep learning is based on artificial neural networks. So it imitates the way that the human brain learns, thinks, and processes data. So this is usually things to do with like computer vision, so with images, videos, and so on. But we're really going to focus on the machine learning part of this today. So just to kind of give more of a distinction between the two. So here's an example of artificial intelligence. I want to determine if a picture is of bread or not bread, or in this case, bread or a pug. You know, it's kind of hard to tell. They look pretty similar. So with just traditional artificial intelligence, you kind of have this if, or, you know, a bunch of these if statements, logical statements. So, you know, if the top is round, if it has ears, it's probably not bread. But you could see that there's going to be a lot of different characteristics that make it bread or not bread. So you might have millions of if statements. And two, because it's images, you know, that might be kind of hard to quantify in if statements like that. So that's where machine learning comes in. So with machine learning, if you want to determine if something is bread or not bread, you would actually take historical data of bread and not bread and use that to train a model. So find patterns in that and then be able to predict on new data to determine, hey, is this picture that I've never seen of bread or not bread? Another way to explain this, so you can hopefully wrap your head around it, artificial intelligence, you would put in rules and data. So you'd have all those if statements, you'd have the data that goes through, and you'd get out your answer. But with machine learning, you would actually give it all of the data, like those images we saw of bread and not bread. You'd give it the answers already. So it'd be the labeled images, and then you'd get out the rules. And then these rules you would use to make predictions on new data. So that's kind of a very basic definition of machine learning and how it fits in with artificial intelligence and so on. There's a lot of different problems that you can solve. And so a lot of people, they say, I want to learn machine learning because it's kind of the cool new thing to do. But if you actually want to use machine learning, you usually want to have a problem to solve first. Especially, a lot of .NET developers have a specific business problem that they have, and traditional programming techniques might not work for it. That's where machine learning may come in. So I want to go into kind of some of the things that you can do, or some of the problems you can solve with machine learning. So one of those might be categorizing items. So one of the tasks that we have, or scenarios, would be data classification. So classification is kind of the task or machine learning task that you do. And so this is when you want to kind of categorize things into two or more classes or groups. So for instance, if you wanted to automatically determine if tweets have a positive or negative sentiment, you would use classification. If you wanted to categorize email as spam or not spam, that might be data classification. Or let's say that you have a website that brings in hotel reviews, and you might want to automatically categorize free response answers into location, cleanliness, and price. Well, you could use machine learning to automatically do that. One that we actually use in some of the .NET repos is a machine learning model built with ML.NET that automatically adds labels to GitHub issues. So that's some examples of data classification. And then you've got image classification. So this would fall under that deep learning category or computer vision. So it's the same as data classification, except you're categorizing images. So for instance, if you wanted to classify if an image is a pug or bread, or if you wanted to classify handwritten digits. In the medical field, they might use this a lot. Say if you're looking at X-rays or some sort of scans and being able to determine if it has, if there is a disease present or not. Something that's similar to image classification is object detection. So for instance, think of self-driving cars. If you wanted to identify the stop signs that are in there, so in this case, you're not just giving the image one class or one category, you're identifying and you're detecting and identifying where in the image these items are, or these objects are. So you might have multiple of them in there. So you might want to detect people in an image. You might want to track a ball and footage of a football game. So those are all examples of that. So for all of these scenarios, you can use machine learning. And you can imagine if you try to do that, with traditional programming, you might not even know where to start with those things. So I would say machine learning is your best bet there. Another problem that you might want to solve is you're predicting a value or a number. So regression is one of those tasks. If you want to predict a number based on a set of features. So for instance, if you wanted to predict the price of a house based on its location, the number of bedrooms, the number of bathrooms, and so on, that would be a regression problem. You might want to predict the sales of a budget based on past predict sales based on past advertising budgets. You could do that. Say you wanted to predict the number of goals a player will score in an upcoming match based on previous performances. So those would all be things that would be covered under regression that you could train a regression model for. Forecasting is similar, especially time series forecasting, but in this case, you want to predict kind of the future based on past values. So for instance, you might just be using past sales to predict future sales. Or this could be things like weather forecasting, or predicting the demand of a product based on past demand. Another problem that you can solve is making suggestions. So recommendation, you all might also like, recommending products to shoppers, recommending movies or songs to users. You can train, usually it is using machine learning for these types of tasks here. Next is ranking. So this would be things like search results ranking. So if you go on Bing, you have the way that it's ranked. So that's usually done with machine learning as well. And then another problem that you can do is finding outliers. So this would be anomaly detection. So if you want to find, change points or abnormal points or outliers, you would do that with anomaly detection. You could identify fraudulent credit card transactions. You might want to get an alert when there is a predicted network intrusion, or you might identify power outages. So as you can see, like with each problem to solve, there's almost an infinite number of scenarios that fall under that. So it's always, critical that you first think about the problem you want to solve when you want to, start with machine learning. Oh, and then finding relationships. So this would be clustering. So this would be, for instance, customer segmentation, or if you want to categorize things that are not labeled, but you want to see kind of the relationships and where they fall, you can use a clustering model here. Okay, and so the workflow for machine learning is usually always the same for training a model. And these are the steps we're going to go through in the MS Learn course later. But I'll quickly go through this, and it's kind of split into two parts, right? So you want to first train your model, and then you want to consume that model or use that model to make predictions. And within the model training bit, the first thing you want to do, well, after you've defined your problem, of course, and understand what your problem is and how you, which kind of scenario it falls under, you first want to get your data. So there's a lot of different data sources. It can be from a database, from files. It can be streaming or batch data. It might be stored on-prem or in the cloud. So there's a lot of different ways. And obviously you'll have to determine based on your own scenario, your problem, your application, how you'll get this data. You also want to think about things to make sure you're, legally and morally able to use this data. So, checking copyright licenses, making sure there's no privacy issues, and checking for bias in that data. Once you have your data, the next step is going to be to prepare that data. So, sorry, I'm with a bunch of dogs here, so they may be going on off as we go. So somebody's at the door. Obviously, they don't like machine learning because they're not liking my presentation so far. So after you get your data, the next step is to prep that data. For machine learning, the algorithms have to take data in a specific format. So for instance, if we're doing sentiment analysis and you have a bunch of text or strings, the algorithms can't really take it in that form. So you have to convert it usually into some sort of numeric vector. So there's a lot of different ways to prep your data. Beyond that, also just getting in the raw data that you have, you might need to clean that data by removing missing values, removing null values, normalizing that data. You might need to split that data into training and testing data sets. So you're able to train with one set of that and then evaluate your model with the other set. You might need to choose which columns you actually want to use for training and so on. So once you have your data prepared, that's when the training comes in. So this is when you choose the algorithms and set up this data processing and training pipeline. And we would call this training is really fitting the model to the data, or finding those patterns in the model, or finding those patterns in the data. Once you train it, then you've got your model. And from there, you can evaluate this model by using a test data set to evaluate against the trained data set. So you want to make sure your model is performing accurately. And there are different evaluation metrics depending on the task that you're doing. So if you're doing, say, classification, a classification task, probably the most common evaluation metric is accuracy. So you're looking at how accurate is the model. But if you're doing regression, it would be slightly different. Usually we use R-squared for that. And a lot of people ask, like, what is a good accuracy? It's really there is no good accuracy. It's, normally the closer to 1 or 100%, the better. But it's, getting a perfect 100% means that you've overfit your model, and it's actually not a good model. So the accuracy, it's going to depend on your scenario as well. So if you're just, classifying articles into, different categories, probably that accuracy is not going to matter as much as if you're using a machine learning model in, say, a medical diagnosis or a self-driving car. So once you have a model that you feel comfortable with, that once you've evaluated it, it's performing well, you can then deploy that model, and you can choose where you want to store or host the model. You can, deploy it, say, offline with an application like WPF. It could just be a console application that you run locally, or you can deploy it to the cloud. There's a lot of different ways that you can deploy it, again, depending on your scenario and app. And then once you've got it deployed, you can start using the model to make predictions. That's what we call inferencing. So there's a few different terms we might use here. There's model consumption, there's inferencing. It all means just using the model to make predictions. And you might notice these arrows here, and they actually should expand farther into the workflow, but it is a very cyclical process. So for instance, if you go and train your data and realize, you evaluated it and the accuracy is not as high as you'd like, or it's not performing how you want, you're going to want to probably go back and retrain the data, and you're going to have to find ways to improve that. Same for if you deploy your model and, maybe it's working fine at first, and then all of a sudden, a few weeks later or a few months later, the model's not working as expected. Well, maybe your data has drifted a little bit and you need to retrain on new data. So there are quite a few ways to be able to improve your model. And here's some suggestions here. If you provide more training data, oftentimes this can be a good way to improve your model. Not always. Sometimes, you already have enough data and adding more won't help. But in a lot of cases, providing more training data can help. Sometimes just more data prep, so filtering out missing values and outliers can help with that. Selecting different features or adding more features or feature engineering. So if you're doing regression, trying to predict the price of a house, say you use, number of bedrooms, number of bathrooms, and so on, you might add more features of the house in order to get a more accurate model and more accurate price prediction. Choosing a different algorithm. So for each task that we've talked about or each scenario, there's going to be a variety of different algorithms for that task. So maybe the algorithm that you chose doesn't work for your scenario. So you would want to try another algorithm. There's also, each algorithm has its own set of hyperparameters or options, and you can tune those or try out different values, which can affect the performance of your model as well. And then cross-validation is another technique, which is just, I kind of mentioned before, where you might want to split your data into train and test data sets. This is just another method for that, where you actually just take the whole data set at once and it splits it into different folds and trains it that way. So that's a bit more advanced, but that is one way that you can possibly improve your model if you have a smaller amount of training data. And so you might have heard of services ways that you can use models that are already trained. So you might be like, why do I need to even train my own model? And sometimes you don't, but it is possible to use machine learning models that have already been trained on data, and you just have to do the consumption part. But this might not always work for your scenario or your domain. And I have an example of that. So let's talk about that sentiment analysis example, where you want to predict whether, say, reviews on products are positive or negative. So if you use a pre-trained model that's just based on general reviews of all products, say you get a comment that says, this is a great vacuum cleaner. Well, yeah, that's probably going to be very positive. But say that you then, and this is particularly for obviously a vacuum, say you get something like, this vacuum cleaner sucks so much dirt. Well, if you're just using that pre-trained model that was based on just general data, you'd probably get a very negative result. Like the sentiment would be predicted as negative because of words like, sucks and dirt. So in this case, if you want to get reviews for sentiment or want to get sentiment for reviews on vacuum cleaners, you might want to train your own model on just reviews for the vacuum cleaners. And so with machine learning, there's a lot of different frameworks, tools, and that you can use for machine learning, right? And in this particular case, the MS Learn course that we're going to go through, we're going to use ML.NET. And what that is, if you haven't heard of it, is an open source and cross-platform machine learning framework for .NET. So it lets you build, train, deploy, and consume custom machine learning models. It's built for .NET developers, so you can stay in the .NET ecosystem to do this. So you can use C# and F#, for instance. And the tools that we have and you'll see this when we do our walkthrough, the tools that we have make it so you don't really need a background in data science and machine learning. And so this is the last slide I have here, and we can get into some questions and then into the course. But this is just a visual of how it's laid out. So on the bottom, you've got the set of APIs that make up ML.NET. So it's Microsoft.ML NuGet package. On top of that, you've got AutoML. So with ML.NET APIs, you'd go and you do all the machine learning workflow that I talked about. You do all that yourself. You'd choose your data transformations, you'd choose your algorithms, your algorithm options, you'd set up that pipeline and you'd train it and get that model. With AutoML, which is short for automated machine learning, it automates that process for you. So it iterates through different models. It tries out different algorithms, algorithm options, and data transformations to give you the best model based on your data set and your scenario. So there is an API for AutoML, but on top of that, we have tooling. We've got Model Builder, which is what we're going to use today, and that's the UI in Visual Studio. And then we've got the ML.NET CLI, which is a .NET Global tool. And it's the cross-platform offering. So you can use that on Linux, Mac, and Windows. So yeah, so with that is the end of my intro to machine learning. And I hope that everyone is now experts. So yeah, if we have questions that we wanted to get to before getting into the course and building our own model together?
Yeah, feel free to ask questions in the chat for Bree, just kind of on this intro to ML section. But don't worry, we'll have other opportunities to ask questions if you think of something later on. We also have moderators in the chat. Hi, Louis. And we can also answer your questions in the chat should we not get to them live. But I'm actually not seeing any at the moment.
Everyone's experts. What?
Everybody's an expert.
I'm such a good teacher.
Actually, that was really amazing. I do think that was a really good explanation of ML, bread, not bread, and then the vacuum scenario of like, I suck so much dirt.
Exactly. Yeah, it's a great one to understand why you might need a custom model in some cases.
Absolutely. Okay. So if we don't have any, I actually just see 2 more questions come through right now. So let's see. Rocco Best from Twitch asks, what about unsupervised learning for that sentiment analysis example?
Yeah, that's a great question. So I actually have a slide on that, supervised versus unsupervised learning. And I guess I'll just, I pressed the wrong button. I can show the slides once I get through here. I put it as more advanced. It was just additional topics if we had time. Let me come back here. Give me 1 second. So in machine learning, there is supervised versus unsupervised learning. So supervised learning means you have labeled data. So it's already tagged with the right answer. And you're trying to find the label of new data. Unsupervised learning is you don't have labeled data and you want to find unknown patterns in the data. So let me give an example of that. So iris flower classification is it's like the hello world of machine learning. An iris is a type of flower, and there's 3 different species of that: Setosa, versicolor, and virginica. And so with supervised learning, you might have this data set of labeled data. So you have your features, which is the petal and sepal width and length, and measurements for that. And then you've got the label or the species. So then what you're trying to do is you get new measurements and you're trying to predict, hey, what species is this? Setosa, versicolor, or virginica? So that would be kind of supervised learning. You have the labels and you want to predict a new label. But unsupervised learning, you don't have the labels. So you might have this unlabeled data, you have a bunch of measurements, and when you go and train that model, it would actually go and kind of segment those based on the patterns that it sees. So say in this case, if it's the same data that we had before, but unlabeled, it would find the 3 groups, and you would want to, and then if you have a new measurements, you would predict which group it falls into out of the 3 groups that it found from the model. So I don't have an example of sentiment analysis with unsupervised learning specifically, but hopefully this kind of gives you insight into supervised versus unsupervised learning. So usually classification itself when you're trying to label it, so positive or negative, is going to be supervised learning. But if you're doing something where you don't have labels, such as some sort of customer segmentation or iris flower segmentation, that's going to be supervised versus unsupervised learning. Or that's going to be unsupervised learning, I should say.
Gotcha. I'm glad that we had those additional topics added. Okay, so Mohit from YouTube asks, what is the advantage of using ML.NET over another library?
Yeah, so it really depends. So I kind of mentioned that ML.NET is built for .NET developers. So we really are trying to enable .NET developers to be able to do machine learning. We're not trying to pull data scientists who love and use Python to use ML.NET, right? We just want to make sure that you all, which I assume a lot of you are, .NET developers, can use machine learning and stay in .NET and be able to do that. So the advantage with ML.NET is you can stay in the .NET ecosystem and build certain models. It's also extensible. So say you are working with a data scientist who's using other Python-based frameworks like TensorFlow or PyTorch. Within ML.NET, you can consume TensorFlow models. So if they went and trained in Python and they either converted to Onyx or they had a TensorFlow model, you would be able to consume TensorFlow models and Onyx models within ML.NET. Another advantage actually is that there's this big kind of issue in the machine learning world where it's really hard to go from experimentation to production. So deploying a model and so on. It's a problem that they're trying to solve, what they call ML ops. But ML.NET makes it really easy because it is .NET. So if you have an ML.NET model, you just have to deploy it as a .NET application, right? So right-click publish, or add it in with your WinForms application, WPF application, and so on. So it's really easy to go from kind of building and training the model to deploying the model as well. So yeah, I would say those are some of the advantages.
Gotcha. So it keeps you all within the same ecosystem, especially if you're familiar with .NET and using all of those tools.
Exactly. Yeah.
Okay, great. And we all want you to stay in the .NET ecosystem.
Of course.
So Mike from YouTube asks, does all of the data have to be labeled in advance?
So I guess it depends. If you're doing supervised learning, then yes, you would want to make sure that all your data is labeled. Otherwise, you wouldn't be able to use it for training. Like everything that you're putting into the algorithm to create the model, it would have to already be known data. If you had data, like within the same data set, if you had data that wasn't labeled, you could use that to try out the model on, right, and see what the prediction would be and consume the model. But you can't have a mixture of, like, at least not in these basic scenarios of labeled and unlabeled data. So if you have labeled data, you'll probably do supervised learning. If you have unlabeled data, you do some sort of unsupervised learning.
I see, that makes sense. Oh yay, we're getting lots of questions, so this is fun. Awesome. So Gabriel from Learn TV asks, generally, how many records are needed to train a model?
Yeah, that's a great question. And it kind of goes with everyone's favorite answer, which is it depends. There is no exact number. It's going to depend on the scenario that you have and the algorithm that you choose and the method you use for evaluation. Yeah, unfortunately, the answer is it depends on the scenario that you have. So there is no prescribed, you should have at least this number. I mean, we do in our tooling, I think for, say, image classification, I think we make you have at least, in the tooling, you have to have at least 5 images per class or something like that, but it's recommended that you have more. And that's kind of one of the things that you can do to as part of the experimentation process when you're training your model is try it with, say, try it with 1,000 rows. And if you're getting a good model, great. You don't have to spend more time training with more data, but if it's not working out for you and you have more data, up that amount and try it with more. So if you go to, there's Kaggle and UCI are 2 great websites for sample data sets, ton of different sample data sets. And you can see kind of the variety in the number of rows or data points in each data set.
Awesome. So that's to arguably say that, as you referenced in your slides, there may be some testing there where you're going to train the model, check the evaluation, see the results, maybe retrain the model, add some more data, check the evaluation. So that's kind of where the cyclical cycle happens there.
Yeah, and Louise mentioned something that's a great point, is that it has to be, representative as well. If you're adding data that's not representative of the problem, then there's no use in adding all of that data to the data set.
That makes perfect sense. Okay, so we have time for 1, maybe 2 more. So we have a question from Learn TV from Zhao. What is better, to build a model from our data or use a pre-proven model? Yeah,
so that's what I talked about with the why would I use a custom model? So again, it depends. It depends on your scenario. A lot of the answers in machine learning is it depends. But if you have something that could be easily, a problem that can easily be solved with a model that's already trained, that's fine. Use a pre-trained model that's already out there that you can or allowed to use. For instance, I know Azure Cognitive Services, they have, a lot of pre-trained models that you can use that are trained on huge domains, right? So it's great because those models have been trained on a lot of general data. And if your problem is kind of general, you can totally use that. But if you're, oh, my screen just, hold on, give me 1 second. My screen just blanked out on me. Okay, there we go. But if your domain or your scenario is more custom, you'd probably want to train it on your own data. For instance, I'm trying to think of a good, I mean, I gave the vacuum cleaner example, but for instance, if you are doing like using image classification or object detection in a like a factory setting, and you have a bunch of machines and you want to identify parts, right? You probably have very specific parts for what you have in that factory that you're manufacturing. And if you were trying to identify and sort it, there may not be a model that already, is trained on that data, and you wouldn't be able to use it. So you'd want to train it on your own data of images of the parts that you specifically have.
I see. That does make sense. Okay, so we have time for one more quick question, but don't worry. If you think of another question, we will have more time later on. So we have, what is a good way to understand hyperparameter?
That's a good question. So in general, the algorithms that are in ML.NET are they're algorithms that are available in other frameworks and languages. So they're kind of like just general algorithms that you can look online and learn about the algorithm itself, and also learn about the different hyperparameters that there are. So just a quick Bing search and a quick, web search, and you can learn about the algorithm itself and how the different hyperparameters affect the model. But in general, probably that experimentation process again, try it out with a simple example, and train the model with the hyperparameter set to something, and then try it again by increasing or decreasing those values and see how that affects the performance of the model. If you want to understand what they mean, then probably a web search. We have some explanations in our docs and API references, I believe, for all the algorithms that we have, that ML.NET has, and all the different options that they have and what they mean. But how they actually affect the model, again, is going to depend on the data that you have, and kind of tuning them and trying them out, and then seeing how they affect the model will be the best for, seeing how they affect the model, essentially, seeing how they affect the performance of the model.
Perfect. Yeah, that I completely understand that. I personally do. So thank you for clarifying. Alrighty. So how do you feel about getting started with the workshop?
Yeah, I would love that. That
Excellent.
sounds like a great idea. Let me pull it up. Okay, so
Yes.
I will zoom in so everyone can see, and I've got it pulled up now.
Yes, all of the resources for this event and tons more actually can be found in the resources link, aka.ms, I think it's /ml-letslearn.net. I can pull it up for you. There it is. Okay. Oh, this is the actual link for the resources and the workshop as well. So feel free to head on over there, and we can, we'll follow along. We'll do the workshop together. So let's get started.
Awesome. I'll zoom in a little more. I want to make sure you all can see it. So all good. I think it's
actually
good.
Do a little more.
More. Okay.
Yeah, there we go.
Okay, perfect. So everyone feel free to follow along. And let's go ahead and get started. So in this Learn course, and together we will be training a predictive maintenance machine learning model with ML.NET, specifically using Model Builder and Visual Studio. So by the end of it, you should hopefully understand what Model Builder is, what problems you can solve with it, how to train a machine learning model, and then how to consume that machine learning model for Model Builder. There are some prerequisites, so you need to know some .NET, an intermediate knowledge of .NET. You have to have Visual Studio 2022, which is currently in preview, with the .NET Desktop development workload installed. So when you do this, the .NET 6 SDK is automatically installed. So that will help with that prereq. And then you need the ML.NET Model Builder extension. So it's included with Visual Studio in this .NET Desktop development workload. So there is instructions on how to do that. And I can pull these up real quick just so I can give a quick visual. So when you modify Visual Studio or you're installing it for the first time, You can choose the individual component if you want. It's also under the .NET workloads, but just make sure you have ML.NET Model Builder checked. And then it should be included once you install that. And these are what we're going to go through. So with that, let us start. So the scenario here is you're working for a manufacturing company that is using industrial devices and equipment as part of its operations. So when one of the devices breaks, it costs your company time and money. So that's why you want to perform kind of predictive or perform maintenance on these. And performing maintenance on the device is really important because the longer that it's broken, the more time and money you're losing. So that's a scenario, predictive maintenance. There's a lot of different factors or features that affect the need for maintenance of a machine, and every device is going to be different. So making sure you're proactive with the maintenance can help minimize the cost and the time that the company will spend when the device breaks. So predicting when it might break before it breaks is really beneficial. So in this scenario, you've been manually keeping track of which devices require maintenance, but as your company is getting bigger, this is becoming more difficult to manage. So what you can do is automate predicting when a device is going to need maintenance using sensor data. And of course, we'll go through what that data looks like in a bit. And so machine learning can help you analyze this historical data from the sensors and then learn those patterns by training the model, and then help you predict whether a machine will need maintenance or not soon. So like I said, we're going to stay in .NET. We're going to use C# for this, and we're going to use Visual Studio to build a machine learning solution. And you don't have to have experience with machine learning, although after my 101, hopefully you do have some knowledge, some base knowledge at least. And for this, we'll be using, of course, ML.NET and Model Builder. So we've already talked, you'll learn how to train and consume a machine learning model inside .NET and using .NET. And yeah, so the goal really is to show you the process of training and using machine learning models to solve real world business problems. So kind of how I talked about in the slides, you have that business problem that you start out with, and then you from there kind of go through the machine learning workflow, which we'll go through together. So first, what is Model Builder? I talked about it a little bit. We know it's ML.NET tooling. We know that it's a UI in Visual Studio. And now we know that it's a workload that you can install, and it's also an extension, which is how we do our updates and everything. So you can use this extension to train and deploy custom machine learning models with ML.NET. And this is what it looks like, and we'll see that once I open up Visual Studio. There's a variety of scenarios here that we can use it for, and I think we get into that here. This is just an explanation of machine learning, which we've already gone through. This talks about a regression problem with the house price prediction, where if the bigger the house is in square footage, the more the house will probably cost. So that would be kind of linear regression. And that's where it gets into the math of things, which we're not going to get into. So what types of problems can you solve with Model Builder? So like I mentioned a lot of problems already in the slides, but these are the ones specifically that you can use AutoML and Model Builder for. So you can categorize data. So that would be data classification, such as organizing news articles by topic. You can predict a numerical value, estimating the price of a used car based on make, model, so on, or in this case, the price of a home. Recommending items, grouping items with similar characteristics, classifying items and images, or classifying images, and then detecting objects in an image. So all these things you can use Model Builder to train custom models for on your own data. And so how can we do this? How can we build a model? So again, we talked about how it's kind of split up into training and then consumption. And so what I'm going to do is go through the training bit, then we'll stop for questions, pause for questions, and then we'll go through how to consume that model. We've talked about what training is. So it's when you apply algorithms to historical data to create a model that captures those underlying patterns in the data and then uses that model to make predictions on new data. Model Builder uses automated machine learning to find the best model, which we'll actually kind of see in action. And this again this kind of follows the machine learning workflow, but is specific to Model Builder. So first you're going to choose your scenario based on the problem you're trying to solve. Then you're going to choose a training environment. So where do I want to train my model? this is going to be dependent on your compute resources, the cost and privacy requirements, and other factors that you might have, based on your company, based on your scenario. And within Model Builder, you have the options to train locally on your computer. Some options, such as image classification, you can actually use GPU locally as well. In most cases, CPU. And then you can also train in the cloud for some scenarios. After choosing our training environment, we will load our data that you want to use for training. You want to define the columns that you want to predict and choose which columns you want to use as inputs for your prediction. Once you have your data set loaded, you're going to want to let AutoML choose the best algorithm for your data set based on the scenario you've chosen. So that's going to be, in this case, the training of the model. And then you want to evaluate your model, see how it performs, and then kind of test it out by making predictions on it. The consumption part is, again, using that trained model that you get from Model Builder. And you can consume the machine learning models from new or existing .NET projects, depending, again, on your scenario. So ML.NET models themselves are serialized zip files. So when you save the model or when you train with Model Builder, it'll come out as mymodel.zip. This can then be loaded. This zip file can be loaded into any .NET application and used to make predictions using the ML.NET APIs. So here's just some examples of application types that you can do. So you could do it through an ASP.NET Core Web API. You can deploy the model as an Azure function. You can deploy it to Blazor, desktop apps like WPF and WinForms. You can even just do a console application or a class library. So that gives an overview of everything. So there's a knowledge check. Let's do a quick knowledge check. So Jamie, I want to know if you were actually listening.
I was. I'm
learning. Okay.
Along with everyone here, I'm learning as well.
Okay. So why don't you tell me, what is Model Builder?
Okay. So Model Builder, I know, is a Visual Studio extension. And then I use it to train and deploy the custom machine learning. So I'm going to go with B.
Okay.
And for
we'll see if you're correct at the end.
See if you can beat me in guessing the questions in the chat.
Yeah. So can you tell me, what does it mean to train a machine learning model?
Based on these answers, I'm going to go with A, applying the algorithms to historical data in order to create an artifact or model that captures underlying patterns that could be used to make predictions.
Are you sure it's not creating an exercise routine? Because that one's pretty enticing.
I think so. I'm going to go with A still.
Okay, sure. All right, so you got the training part down, maybe. We'll see. What does it mean to consume a model?
To consume a model, I'm going to go with B, using a trained machine model to make predictions on new and unseen data.
Okay, let's check your answers. Nice job. You've gained lots of experience points here.
200.
200. Wow. I'm going to continue without saving progress because I'm in a guest thing here. So, and it looks like in the chat, people were paying attention. So good job.
Oh, good job, everyone.
Yeah. All right. So let's move on to the next section, and then Jamie, I'll have you come back for the next knowledge check.
Okay, great. I'll keep paying attention.
Awesome. Good. Cool. So we talked about this already. We're breaking it down into these steps here. We're going to choose our scenario, choose our training environment, load and prepare the data, train the model, and then evaluate the model before getting into questions. So we're going to start the training process now. So this is what we have to do first. We have to add a new machine learning model item to a new or existing .NET application. So in this case, when we add a machine learning model or ML.NET machine learning model, it's going to add a file to our project with the mbconfig file extension, and you'll see that once I get into the steps. This mbconfig extension, it's just a JSON file, and it lets you provide a name for your model. It lets you collaborate with others on your team via source control on the steps, and then it helps save the state of the model. So previously, when you added machine learning to your application with Model Builder, it would just open up the UI and there was no saved state. So if you went through and then closed out, you had to start over. But in this case, this mbconfig lets you persist state, and at any point in the training process, if you close it, you can come back to where you left off. Yeah, so let's talk about what scenario we're going to choose. We already talked about all these scenarios. It's going to describe the problem we're trying to solve using our data. The scenarios map to different machine learning tasks. So the scenario itself would be, I want to organize news articles by topic. Well, that's going to fall under the data classification or categorizing data task. And again, we talked about supervised and unsupervised learning already. So again, supervised learning is if it has a label. If that's known, if it doesn't have if your data set and data doesn't have labels, that's going to be unsupervised learning. We can kind of split the tasks, the machine learning tasks that Model Builder has, into supervised and unsupervised. So classification, which can technically be split into binary and multi-class classification, but we kind of just group it into one. Binary is if it has only two categories, positive or negative sentiment. Multi-class is if it has two or more categories, if you want to do the hotel review example that we talked about. Then there's image classification. So binary and multi-class classification has to do with the tabular data. You have rows and columns of data. And then image classification is with images, of course. And then you've got regression, which is also a supervised task. This is predicting a value. Then unsupervised tasks, clustering and anomaly detection would fall under those. These are the scenarios in Model Builder. I think we've talked about all of these scenarios already. And you can kind of see what the scenario maps to the task. So we really try to take a scenario first approach in our tooling and in ML.NET in general, because we know regression might not mean, or linear regression might not mean something to someone who doesn't have a machine learning or data science background. Same for binary and multi-class classification. We just want to simplify it and make it really easy to be able to map your problem to the scenario that you want to choose. So each scenario, again, falls into a different task and has an infinite number of use cases. So for our example, we have a predictive maintenance example. So it's going to depend on what your data looks like, how the model is going to look like, and what scenario you're going to choose. But in this case, our label, and we'll see that in our data set, it's going to be a binary value. It's going to be 0 or 1. So 0 is the machine is not broken, 1 is the machine is broken. In this case, we're just going to do data classification. So we're going to classify new data based if it's 0 or 1, or broken or not broken. And that would be specifically binary classification. But in our case, we just need to know data classification. I talked about the different training environments. So again, I talked about how the scenario will, or depending on the scenario, will depend on what training environments are available. So in our case, for data classification, where local GPUs or local CPU is the only option currently available. And that's fine. Like for our use case with the data set that we have, it's kind of a sample data set, it will work completely fine on local CPU. But if you're doing something like image classification, where that data is going to be a lot bigger, the size is going to be a lot bigger, it's going to be really advantageous to either, scale out or be able to use your GPU locally, or scale out to the cloud with Azure, which you can do from Model Builder. And you can take a look at this chart to see what scenarios are supported for which training environments. So this kind of goes into when you might use one over the other. So you might decide to train locally if cost is an issue. So training locally doesn't cost money. Since you're using your own computer's resources. There might be certain scenarios where you don't want your data to leave your computer or data center. So, I know a lot of scenarios like with the government or something like, or with private data, you can't send that out to the cloud. So you'd want to train that locally. Azure environments, like I said, are great for scaling out for those resource intensive scenarios like image classification and object detection, and it can speed up the training process. If you don't have a GPU locally also, then you might want to use the Azure GPU for that, or the cloud. That's some cloud. So loading and preparing data, once you have selected, we're going to select the local training environment. Data obviously is very important when building machine learning models. If you didn't have data, you can't build a model. So in Model Builder, you're going to choose your data source type. You're going to provide the location of your data, and then you're going to choose the column purposes. So for data source type, there's a few different options. You can have a delimited file, so it can be comma, semicolon, or tab separated. You can also have the data locally or in a remote SQL Server database. You can have images, so JPEGs or PNG images. And then for object detection scenarios, there's an extra step you have to do, which is adding the bounding boxes or labeling the images that way. And we recommend this tool here, but we don't have to get into that because we're not doing object detection. You also have to specify the location of your data. In this case, I'll just have it locally once I download it, and we'll go through those in the steps. And then once you select your data source and your data set is kind of loaded, you'll get a preview of the data set in Model Builder. And Model Builder does its best to parse the data and to identify whether the data set has a header, what the column names are, what the type of separator is, what the different data types are, and so on. But you do have the option to change those. And I think that mentions that here in the advanced data options. So if Model Builder happened to not parse it correctly, you can change those in the advanced data options. You also want to choose a column purpose. So in data classification and value prediction, you want to choose which of your columns is the column you want to predict. This is commonly known in machine learning as the label. So in this case, that column of whether it's broken or not, 0 or 1, that column is going to be our label column, and that's what we will choose. The other columns that you want to use as inputs to the model to make the prediction, those are going to be called the feature columns. So you'll want to choose which are your feature columns. You can also choose to ignore columns that you think won't contribute to the final prediction. So let's take a look at the data set. There's a link to where it's from. I mentioned UCI before as a great resource for finding sample data sets. This is from UCI. We've put the source here, and it's this predictive maintenance data set. It's again, a sample data set that reflects real predictive maintenance data encountered in the industry. It has 10,000 data points or 10,000 rows and 14 columns. And this is a preview, so the first 2 rows of what that looks like. So you've got this UDI. So this is the rows index. You've got a product ID, so it's just an identifier that contains a product type category and then the serial number. You've got the type, so you've got LM or H for low, which is 50% of the products, medium and high. And then you've got air temperature, process temperature, rotational speed, torque, tool wear, which these would all be great features to add for predicting whether it's going to fail or not. And then, of course, you got the machine failure. So that's going to be the 0 or 1. This is going to be our label column, if you remember. And then you've got these bunch of 3-letter acronyms, TWF, HDF, and so on. This is the machine failure mode. So it's a specific reason why it failed. So one means that that's the reason that it failed. So I don't know exactly I can't remember what OSF and these stand for, but this would be like the reason that it failed. In this case, we're not going to use all of the columns in the data set because they don't really contribute to the prediction, or they might contain redundant information. So we already talked about, because we want to predict whether the machine has failed or not, or is going to fail or not, then the machine failure column is going to be our label. And then we're going to use the different various sensor column data to make our final prediction. So the failure modes are useful in diagnosing the cause of the failure, but they're not useful for our use case because we only want to know whether a machine has failed or not. So it's kind of redundant. If there's a 1 in one of those columns, then we know that it's failed. So we already have the machine failure column. So we won't actually be using those 3-letter acronym columns that are the machine failure reasons. Okay, so that was a lot of knowledge. We've got another knowledge check Jamie, if you're ready.
I'm ready.
Awesome. Okay, so what's one thing that files with the mbconfig extension allow you to do?
I'm going to go with it saves your model builder state.
Okay. And what is the value you're trying to predict commonly known as? This is a good one.
Oh, I know. I was like, is it label or feature?
I know.
What is the value you're trying to predict commonly known as? Okay, so the value you're trying to predict. I'm going to say label.
Okay. And what might be a reason that you choose Azure or cloud training over local training environment?
Oh, it said this specifically. You don't have a GPU or a computer with enough CPU or RAM for resource-intensive scenarios like image classification.
Okay. Congratulations, 200 more experience points. I can't wait till the end when we can use all our experience points to buy prizes.
Ah,
Just
you're
kidding,
doing
you can't do
amazing.
that. Awesome job, Jamie, and everyone. I saw a few people in the chat also answered, so
Yeah, great
good
job,
job.
folks in the
Thanks for
chat.
paying attention.
Appreciate it.
Cool. So I will continue on and
Cool. So,
see you in the next knowledge check.
Yeah.
Sweet. So let's talk about training and evaluating models in Model Builder. When you're training in Model Builder, you've selected your scenario, you've selected your training environment, you've loaded your data, now you want to train that. So we've already talked about what training is, but with AutoML, this AutoML training is that experimentation process of trying to find the best model. So in most cases in Model Builder, you just have to provide the amount of time you want to train for and then hit start training. And the amount of time that you give it to train will be the amount of time that AutoML iterates through different models. So through different algorithms, algorithm options, and data transformations. So here's a kind of a general, like how long should I train for based on my data set size. This is assuming local CPU and tabular data, I believe. So you can see, if you're in between this data size, you're going to want to train for 10 seconds. And it actually, Model Builder will automatically kind of assume based on your data set size how long you should train for. So it'll change what's in the text box, but you can totally override that as well. And again, these are just a guide. So there's other factors that will affect how long you should probably train for. So if you have a lot of feature columns being used, so the more columns you have, you might want to train for longer. And the type of columns that they are, the specific machine learning task, and then of course the resources available on your computer for training. So it's a general guide which can get you there. And of course, if you try out 10 seconds and it doesn't work, try out more and see what happens. So this is actually a tip. Someone asked about this, how much data should I have? So we have a tip that says to use at least 100 rows or more than 100 rows. So there's a good tip, I guess. Again, the answer depends. So I talked about how it finds the best model. It uses this automated machine learning. It identifies a set of data transformations, algorithms, and it tunes those hyperparameters or settings of the model to create the model that best suits your data. And I guess I didn't mention this, but it uses a specific evaluation metric to determine the best model. So in the classification case, it's using accuracy. So whichever model has the best accuracy in the given amount of time that it was given to train, that's the model that's going to be selected for you. And the evaluation metric, the optimizing evaluation metric will change based on the task that you have. So then once you're done training, you're going to notice that under the mbconfig file, there's going to be a few more files that are added. So you're going to get this .zip file. This is the actual, I talked about this, the actual ML.NET model, which is that serialized version of your model. And it's going to be whatever you named your model.zip. Then you're going to get this training.cs file. So this is going to contain the model training pipeline. So the best model that AutoML chose, whatever algorithms, options, and so on it chose, it's going to put into this training.cs file. You might be asking, well, why do I need this? I can just use, I can use Model Builder again. Well, every time you train with Model Builder, you may end up with a different pipeline. Also, if you wanted to retrain your model on the same pipeline, it's going to be really important that you have the training pipeline that was used for this model. And I kind of mentioned this, like if your data changes, you might want to retrain the model with new data and so on. So you can also use this training file in like CI/CD for automatic retraining. So it's really important to have this training.cs file. Then there's the consumption.cs file. So this contains the classes that define the schema of your model input and output. It contains a predict method, which loads the model, creates a prediction engine, which is a convenience API for making single predictions, and then calls that predict method. So it kind of wraps that all up into one thing so that you just have to call predict. It makes it really, really easy to be able to use your model as soon as you get it from Model Builder. And then you're going to want to evaluate your model. So again, Model Builder already does this for you, but once you want to test how well that it makes predictions. So you can use it. You can look at the evaluation metrics, which again are going to be specific to the type of task that you did. And in this case, we're doing data classification. So we're going to be, and it's binary. So we're going to be looking at just accuracy. And we're looking for the closer to 1, the better. And then depending on your scenario, there's going to be different optimizing of evaluation metrics. But in like looking at the evaluation metrics is one thing. You're also going to want to try and like try out your model to make sure that it's making good predictions. So say that you get, 100% on your model, which is, you'll never 100% means you've overfit the model. But then you go and you try out the model and you're getting completely wrong predictions than what you would expect for sample data, then you probably want to reevaluate. And by reevaluate, I mean retrain the model with some of the ways that I showed you how to improve your model before. And here's some more tips for improving your model. Again, adding more data, and this is a great point, is making sure it's representative data, providing more context, so adding more features, representative features, and exploring more algorithms and so on for improving the model. Okay, so from here, I think this is the exercise where we actually get into training the model, which is awesome. So I'm going to do it on Visual Studio, and you all can follow along. Hopefully at this point, if you didn't have it before, you were able to download Model Builder. So this is what we're going to do. We're going to create a C# class library to add a machine learning model to. So we're going to open Visual Studio, we're going to create a new project and so on, and create a class library. And I'll show you that in a second. Yes, Jamie.
Yeah, I was just wondering, is this still the first part of the workshop, or?
This is the actual just like going through and how to actually do it step by step in Model Builder and following along. Yeah.
Okay, perfect. And then the second part will be consuming and prediction.
Consuming, exactly, yeah. And so I figured we'll take some questions after we go through this in case anybody gets stuck.
Yes, perfect, thank you.
Awesome. So let's name this predictive maintenance. I'm gonna copy that. And we'll do a .NET 6 application. So I had Visual Studio here. Give me 1 second. Here we go. So I'm going to create a new project. And it will be, once it loads, a class library project. Give it a second. With streaming and sharing my video, sometimes it doesn't get very happy. So we're going to do a C# class library, and we're going to name this predictive maintenance, and next, and it's going to be a .NET 6 application. So let's create. And while that is creating, while it's loading, let's go back and see what our next steps are going to be. So this is the part we're going to add machine learning to our project. So once it opens in Visual Studio, we're going to go to the Solution Explorer. We're going to right-click on our project. We're going to select Add a Machine Learning Model. And you can see right-click Add, and I'll do that in a second. And then it's going to default already to Machine Learning Model ML.NET in the Add New Item dialog. And that's where we're going to see where we can name our model. So I'm going to copy this here and go back to Visual Studio, hopefully. Oh, it's still creating. Okay, we'll give it a second. I didn't like that I minimized it, I guess. So I'll keep going through this and then we'll go through it together in Visual Studio. But we'll add that, and then you'll see that NB config file added to your project in the Solution Explorer. And it will also open up the Model Builder UI. So it opened up on my other screen. Let me bring it over. Okay, and Jamie, let me know if it's too small as well, but I have it on 140%, so I can always zoom in a bit. So like I said, should I zoom in a bit?
Yeah, just a bit.
Okay. Yeah.
I feel like it can never be too big, but I also am wearing bifocal, so it's
okay. Oh gosh. Okay, I think this is a little better. So I'm going to right-click on my project and add a machine learning model. And you'll see it opens this Add New Item dialog, and we'll load the templates, and it'll default or auto select the machine learning model here. And let's call it Predictive Maintenance Model and add that model. So again, we'll see that NB config added here. MB config, and then you'll see the UI opened here. So I think we already went over which scenario it's going to be, but let's go back through to make sure we're following it step by step and nobody gets lost. So again, we're going to choose the data classification scenario because we're doing 0 or 1. Is it going to fail or not? So that's going to be this data classification. We're going to choose our environment next. So it's going to be that local CPU environment. So let's do those 2 steps together. So data classification, classify text data into 2+ categories. And again, local CPU will be the training environment that we choose. So here we're going to load and prepare our data. So here we actually have to download our data set. We talked about it before a little bit, but I'm going to download it along with you all. So it's going to be this .csv file. And it's going to, if you just click on this is from the UCI website. I've obviously downloaded it before, but we'll just call it this, and it's opened here. So it's going to be in my downloads. So save it wherever you want on your computer. It will save with this, and it's a CSV file. So next, we're going to open this file in any text editor. Normally, we wouldn't have to do this step before, but there's some special bracket characters in the header, which Model Builder doesn't like to process as headers. And we're working on actually fixing that, I believe. But we want to update the headers so that we don't have these brackets here. So you can see the updated one is we're just going to get rid of the metrics that are used. So I believe that would be Kelvin for temperature, but we're going to get rid of those so we don't have those brackets. And so I will open up my downloads. I'm going to open it. I'm just going to open it in Notepad. And I'll bring over the Notepad once you see it. Once it opens up here. So yeah, so here you can see the data set. You can see it has these brackets. So I'm going to get rid of these brackets from the header so that you don't have any issues with the data preview. I don't remember what torque is measured in. Does anyone remember? Okay. There we go. So from there, and you can see it's a CSV, it's separated by commas. So we're going to save that, and that's just saved in my downloads here as a comma. It should save as, let me make sure, as, yeah, .text is fine, and it's a CSV. Okay, so next, within the data preview here, we're going to select just from a file. We're going to select our data from a file. We're going to browse and find it on our computer. And we're going to choose the label column, which again is going to be that machine failure. So going back to Visual Studio, you can see I have the options for file or SQL Server. And I'm going to keep the file because that's where I have it. And I actually have this one in my downloads, and it's going to be this one, I believe. And once it loads, you'll see that it's going to show us a preview of what that data looks like. So you can see it tells us there's 10,000 rows. Oh, I must have chosen the wrong one. Give me 1 second. So this is the issue I was talking about. If you don't update the brackets, it's going to do this weird thing where it doesn't show you the data, even though the data is there when you train it. So let me grab the other one to make sure we're doing this right. And I believe it will be, I think I just opened the wrong one. Let's try this one.
Bree, would you mind zooming in just a tad?
I would love to, but how do I do that?
I think, do we have a zoom feature? This is in Visual Studio, correct?
This is in Visual Studio. Yeah,
Command plus.
There is no because it's UI, I guess. Unless there's a way to do general font
updates. Okay.
Do you know if there is? I don't know.
I usually just do either a command plus or actual pinch to zoom. But
yeah,
keep going, update the new one, and then I'll try and get an update for you.
Okay, yeah, let me know if there's a way to do that while I try to figure out which is the right data set that I have. Make sure you put it in a place that you know and isn't going to get confused with other ones, because that's exactly what I've done since I've been practicing this for you all. Okay, let's go ahead and try this again. And I'm just getting rid of those brackets so that it's parsed correctly, because it doesn't like brackets. Okay, so I'm actually going to save this somewhere else so that I don't get it confused. I'll just save it to my desktop here. Okay. Oops. And that's going to be right here. And there we go. Okay. Third time's the charm. So I've got my CSV file. It's 10,000 rows. It's 10. It's showing the first 10. So you can see kind of that 1, 2, 3. We talked about this being I think the label or the index, I mean. And we've got all our columns here. So our column to predict is our label, which, remember, Jamie got that correct. Oh, Windows button and ++. Okay, I'm going to try it. Oh, the magnifier. Okay. So cool. So I guess I can kind of show you up close what this looks like. But I chose file as the input. I got it from my desktop after I got rid of the brackets in the header. And now I'm selecting my column, or my label column. This is a little trippy here. We know that we want it to be machine failure. And from here, you can see kind of the data preview. So is it Windows++ to also get rid of it? That's the question.
Yeah, I think Windows Plus will just zoom the whole screen. Windows Escape should make the
Windows Plus.
Oh, yours isn't working. Okay, well.
I have Windows 11 now, so maybe things have changed. I don't know. But I can try and do the Windows Plus for like smaller things, or like zooming in, and then, yeah.
Okay.
But yeah, this is the data preview, so you would have seen this in the data set anyways. Let's go back to this, which hopefully you all can see. We chose machine failure as the label column, and then we're going to go into the advanced data options. We talked about how some of the columns we don't want to use, those 3-letter acronym columns, because it was kind of redundant information. So we've put a nice little handy thing here of how we want to do that. So we're going to ignore the first one because the index doesn't really contribute to the final prediction at all. We'll keep the product ID, the type, and so on as features. So all of these things are going to be features. And then we're going to ignore all of these columns as well. And I believe the data types should all stay the same, but you can make sure and compare this with the Model Builder advanced settings. So advanced data options is underneath the column to predict, and Windows Plus. And you can see here, the UDI is one that we're going to ignore. And the rest of these product ID, type, air temperature, and so on are all ones that are going to be features. And these 3-letter acronym ones are the ones that we're going to ignore. So just continue to do that. I'm going to take it off here. Ignore all these columns because we don't want to use them for the final prediction. And we want to predict the machine failure. So we'll save, and it says, 6 of these columns are ignored. And we're going to go to the next step. So now we're going to train, and I believe that will be the next step here, training your model. So we're going to set our training time. In this case, let's set it to 30 seconds. We talked about how the amount of time we want to train is going to depend on our computer's resources. Well, right now, it's, I'm live streaming, sharing my video and screen. So 30 seconds should be good enough, though, to find a good enough model for this sample. So we'll hit start training for 30 seconds, and we'll see this kind of output in the output window that shows us the models as they're being explored. So coming back here, I'm going to put this as 30 seconds. I don't know if hopefully this Command Plus is working for you all. I mean, Windows Plus. 30 seconds, start training. So you can see. So coming down to the output window down here, this is where it's going to kick off that AutoML process. And so you can see it's got an index of the trainer. So trainer is interchangeable with algorithm. So as it's going through the time, it's going through these different algorithms, and you can see what the different accuracy, what the different iterations are, how long it's spent training that model, and the evaluation metric. So oh, great. Is there something I did wrong here? Let's get out of this mode here. This probably has something to do with the way that I saved it, classic. Let's try training for a smaller amount of time because it didn't seem to matter. And let's see what happens. Otherwise, we're going to be doing some live debugging here. So finalizing that. So you can, if you don't find the model that you want, you can train again. And let's see, it's finalizing the model. There we go. So I don't know what happened there, but training is now complete. I just ran it for another 10 seconds. And the training results, we have an accuracy of 98%. So that's pretty good. I'm using this Fast Forest OVA model or algorithm or trainer. And it trained in about 10 seconds. In that 10 seconds, it explored 5 different models. And it gave us a model with 98.26% accuracy. And we talked about the code that's going to be generated. So it's going to be this consumption.cs and training.cs. That's going to be over here. So if we come here, you can see the consumption and training code, and the zip file has been generated for us as soon as it's done training. And if you train again, like if you retrain, then it's going to overwrite those files with the newer model as well. Okay, so we're done training our model. And let's go back to see what is next. Evaluating your model. So we looked and saw we're happy with the accuracy. Now we want to test our model, which we can do right in the UI to make sure that it's getting good predictions. Let's come back and evaluate. So this is where we can try our model. We have kind of what we saw before. We saw the accuracy of 98% with the Fast Forest OVA model. And then here's sample data. It's pre-filled by row 1 of your data. So just to give you a place to start. So this product ID, this type, the air temperature, and so on, and then all the way down to toolware. So if we hit predict over here in the results section, so remember 0 means not machine failure. So it's predicting with 99% certainty that the machine is not going to fail or not failing. So probably what you're going to want to do is try out different values here. I don't know. I mean, I guess machineware would probably, or toolware would probably get it closer to needing to be replaced. Maybe a really high temperature. I don't really know. I don't know much about machines. You would know in your own scenario, but let's predict it with those values and see if that changes. So it's a little bit less certain, but this is where you would go and experiment. Let me try different things. Let me try, like if it's going really fast, maybe you would expect it to, so say that the rotational speed is really, really fast. It's been the toolware is, a really long time. It's really old. So then you might predict that it's going to fail. So in this case, it did predict machine failure with 73% certainty. And so we're happy with our model now. We've trained our model. We've got a great model for this use case. And I think, so that kind of concludes the model training portion. So we selected our scenario, we selected our training environment, training on local CPU for data classification. We trained twice because there was an error on the first part. We trained, and in 10 seconds, because that was how much time we added restarting the second time training, in 10 seconds, we were able to get a model with 98% accuracy, which we then tried out that model in the UI, and we got the consumption and training code generated for us. And now we're ready to consume it. So that's the end of part 1. So if there's any questions that I can answer.
Yeah, we do have a couple questions. So feel free to ask your questions in the chat now, and we'll definitely get to them. So the first question is, can we use these packages with Jupyter notebooks?
Can you say the question again? Sorry.
Is it possible to use these packages with Jupyter notebooks?
If you can do C# and .NET in it, then yes. Then you can use ML.NET, Microsoft.ml packages. You can't do Model Builder in it, but you can't use Model Builder in it, but you can do ML.NET. There's actually also like .NET Interactive notebooks. So I know VS Code has an extension to that, and we just released kind of a preview experimental version of notebooks in Visual Studio, which if we have time at the end, I can totally show. And yeah, so I think that answers that question. You can use ML.NET in interactive notebooks.
Okay, cool. Good to know. Second question. Can you talk a little bit more about AutoML? Like, is it appropriate for beginners, would you say?
I would say it's actually recommended for beginners. So what's really great about it is, you don't need to have that knowledge yet. So when we first released ML.NET, there was a lot of people said, I don't know, we just had the framework, we didn't have the tooling. And people were like, I don't know what algorithm to choose. I didn't study data science. I didn't do machine learning. I don't know what settings I'm supposed to choose, and so on. So that's kind of where the tooling came from, is like, you can just put in your data and your scenario, and it will train it or go through those trainings for you and choose the best model. But from there, because it has the training file, you can then open the training file and see what was chosen and kind of start to understand, like, okay, this algorithm was chosen. Maybe I should go and look more into this algorithm and understand why. Or here are the options that it chose based on my data. If I change these, how would that? And you can take it and you can change the hyperparameters and see how that affects the model. So AutoML is definitely a great way to start. I wouldn't recommend just using AutoML and then not understanding your model, like keeping it a black box. I think it's important to be able to understand why your model is making the predictions it is and being able to explain it, which kind of falls into model explainability and responsible AI. But yes, definitely recommend AutoML for beginners.
Cool. Yeah, it seems pretty awesome. Okay, we have time for a couple more questions before the next portion of the workshop. Which deep learning architecture does ML.NET use for image classification? Like ResNet 50 or etc.?
Yeah, great question. So just to explain to everyone else, we have, as part of ML.NET, there is an image classification API. So this allows you to use a process called transfer learning for training custom image classification models. And it's the same thing that happens in Model Builder when you're training an image classification model. This is built on top of something called TensorFlow.net. TensorFlow is another machine learning, or deep learning framework that's in Python. But there's Sci# is an open source project that has a .NET implementation of that. So TensorFlow.net is the underlying framework that's being used for our image classification API. Just to give a little bit of background, I actually, and of course for this actual question, I don't remember which architecture is used by default. And maybe Louise, you can pull up the doc and let us know. It's either Inception or ResNet 50, and I believe you can change them out. There's a few that you can change out. And there should be some API references there. Again, maybe Louise can pull those and post them in the chat. So I'm sorry I can't answer that direct question because I can't remember which architecture. But yeah, we'll get that answer for you.
Yeah, we'll have someone answer that in the chat.
Yeah.
Can you connect .NET with TensorFlow?
So I guess it depends what you mean here. You can train a model in TensorFlow and then consume TensorFlow models in ML.NET without having any dependencies on Python or anything. Same for like PyTorch. If you train a model in PyTorch, you can convert that to Onyx. You can convert Onyx models in ML.NET with the Onyx runtime. And then, as I mentioned before, our image classification API runs on top of TensorFlow.net. So that's kind of a connection with TensorFlow there. So hopefully that answers your question. Those are the ways that kind of ML.NET and TensorFlow are connected.
Okay. Yeah, that makes sense. Okay, one more question really quick. Yeah. Is there a way to create an object detection model without using Azure?
That's a great question. Right now, no, but we are working on it. So it's in progress. Yeah, so our goal with Model Builder is to be able to have all the training environments available for all the scenarios. It's just a work in progress right now. It's a great question.
Cool. So features to come.
Yes.
Okay. With that, we actually have time for one more quick question. William from Learn TV asks, what is the difference between image classification and computer vision?
Great question. So image classification is kind of a subset of computer vision. So computer vision kind of describes the tasks that would kind of imitate human vision. And so it would be like images and videos and such. So image classification is like a type of computer vision, just like object detection is a type of computer vision. So that's how they're related. Image classification is a type of computer vision problem.
Gotcha. I see.
Yeah.
Okay. Feel free to keep asking your questions in the chat. We do have moderators, and we should have some time in the end to answer a few more. For those of us just joining, welcome. We're about to get started with our workshop, or I guess the second portion of our workshop, which can be found at our resources link, if I can get that pulled up here. My name is Jamie Singleton. I'm joined with Bree Ackman. We're going to be, and yeah, we're covering ML.NET. Yeah, and I did get a bit more info on the zooming.
Okay.
Apparently,
tell me.
in Windows 11, there Control-Alt-M cycles through the modes, and there's a lens mode which pulls up the magnifier.
Okay.
But if we do Control-Alt-F, it will do full screen magnification.
While I have it open?
Yes, while you have it open.
Okay, I'll give it a try real quick and see. And Control-F. Something's happening.
Oh no.
Oh wow. Something's happened. Okay, so it is full screen now, but I think I prefer the other one actually. I guess it's up to you all, but
yeah, maybe some comments in the chat. Do you prefer this version or using the magnifier?
Let me know. And it's only in Visual Studio. The rest should be fine. And yeah, just let me know.
Any comments? Let's see. No preference at the moment. So
cool. I guess we're jumping into the browser anyways right now. So
perfect. So we'll go along from there.
Cool.
Great. Thanks.
Okay, so let's talk about consuming machine learning models. We've got a model we like. Accuracy is great. We've tried it out, and the predictions seem right. So now we want to consume that model. So there's a few ways you can do this in Model Builder or in .NET in general. Model Builder itself will give you a code snippet that you can copy paste into your app. So for instance, if you had a console app that you started with, you could copy paste this, put it in the console app and run it, and it would work automatically. It just uses, again, that first row of data as a sample, but then you can change out what the sample input actually is, or the input. So yeah, so it also automatically adds a reference to your project when it does this. So if you're adding your model to another project that's a different project, you'll want to add a reference to your model from the project you'll use the model in, and then add that code snippet. And what the code snippet does, which we'll see in a second, is it creates an instance of your model input. So in this case, all those features that we saw, and then it calls that predict method that I talked about in the consumption.cs file. Additionally, in Model Builder, there are project templates. So these are ones that can be auto-generated, but they're not like auto-generated. You select if you want them to be generated. So maybe auto-generated is the right word here. So there's a few templates right now that Model Builder provides. There's a console application. So this would create a whole new project in your solution that is a console app that will use your model to make predictions. There's also a web API template. which is an ASP.NET Core Web API using the minimal APIs. So if you choose to add that, it'll create a new Web API project, and you can just right-click publish that and it would work, or run it locally and try it out. And here it talks a little bit about the structures of each one. So for the console app itself, you'd have your program.cs, where it'll be pretty much the same as what you would copy from the code snippet that gets generated from Model Builder, which would, again, create an instance of the model input that you want to give into the model. It will use the predict method on that input and then display the result to the console. And it will include that mbconfig file with your model in that as well. The web API will also have a program.cs. It's a little bit different though. And it's kind of in this note here, it talks about it. So it's a little bit different in how the web API project predicts. So it registers a prediction engine pool as a service using dependency injection. So I talked about the prediction engine a little bit. It's a convenience API for making single predictions. There's also a way to make batch predictions, but in this case, we want to get input in from, let's say, a user or a console, and then get just one prediction out at a time. That's what we use the prediction engine for, but it's not thread safe. So, and you have to create an instance of it everywhere it's needed. So as your application grows, this can become really unmanageable. So to make sure that you have improved performance and thread safety, you use this dependency injection and a prediction engine pool service. So that creates an object pool of prediction engines for use throughout the application. So whenever you have a web app or any app that's not, that might not be thread safe, you'll want to use prediction engine pool versus the prediction engine. Okay, so with that, this is just how we're going to do that. So in this case, we're going to add a console application of the solution. So again, this is what the consume step is going to look like. And we'll just add it to our solution, and then we can kind of dig into the code that it gives us. And then we'll run that project. So coming to this consume step here, I'll magnify so you can see. This was the code snippet I was talking about, where it's going to create new sample data. So again, here's your model. So you're going to have this model input, and you're going to set the feature. Let's see if I can scroll slowly. You're going to set the features here. This is based on the first row of data, but for new, you'd want to predict on new data, so you could just swap this out with whatever you wanted, whether that's hard-coded or sent in from somewhere. And then you're going to call this predict method on your sample data in order to return the result. So again, I could copy paste this and use it, but in this case, I want to look at the project templates. There's that console app one that I talked about, the web API one that I talked about. There's also a notebook, which I can maybe show you if we have time at the end. So let's go ahead and add the console application of the solution. We can call it whatever we want. I'll just keep it to this. It's a very long name, but that's okay. So we'll see here that this predictive maintenance model console app gets added to my solution. Hopefully you all are not getting dizzy with this, with the magnifier. And it adds all those things that I talked about. So it has the mbconfig. So if you open that up, it would open up the UI again. It has the consumption.cs and the training.cs, and then your actual model. And I talked about these files, but let's actually look inside them to see, to see the code, because I don't think we've seen any code so far, except for the code snippet. I talked about the training file, and with this, I won't need this, so I'll close out here. So this is the training.cs file, and here's that Microsoft.ml package that I was talking about. This brings in ml.net. And so we're looking at kind of the pipeline that was built, the training pipeline, which is going to be those data transformations and those algorithms and algorithm options. So let's come down here. This is our pipeline right here. So in this case, when AutoML was going through, it shows this one hot encoding data transformation. It replaced a few missing values. It featureized some text. So I told you text can't be given to a machine learning algorithm. It has to be kind of vectorized into a numeric vector. Then it concatenates some of that, map value to key, and so on. So these are all data transformations. And then you get into the trainer. So we chose a classification task, And there's going to be a kind of a catalog of trainers. And in this case, it chose the one versus all, or OVA. And if you come here, you can see here's some of the hyperparameters that it chose. So in this case, number of trees is 4 and feature fraction is 1. Again, you probably won't know what this is if you're just starting, but if you go to our documentation, and then it's again common, like this, the different algorithms that it shows are going to be pretty common. So you could you'd be able to find them out there, even if it's implementing them in Python or whatever language. The information about the algorithm will remain the same, so that you can understand how it works and then what the different hyperparameters are. But you can also go to our docs to take a look at that. So then after it returns, so it will return this pipeline up here, and then it will get the model. So it does pipeline.fit. We talked about fitting data to a model with our data. So our trained data, which we've already loaded right here, and we'll get back that model and return the model. So this is the pipeline that you could use if you wanted to retrain the model or understand how your model is working. Then we have the consumption.cs file. So this is the other file that was generated from the mbconfig, as well as in the new console application. So this is going to be really important. This is the schema of data for your model input. So you can see here, for instance, torque is a float, and so you'll just have each column here that you chose. So it has all our different feature columns, and if you come down here, model output. So what we're going to get back from the model is going to be a prediction. So it's that 0 or 1. Is it failure or not failure? We're also going to get a float array of scores. This is going to be, and you saw this in the UI, where it kind of had the confidence of how or probability of it being that label. So when it's at 99% next to the 0, it's 99% sure that it's not a machine failure. So those scores are kind of stored in this float array here, so you can access them. So then here is where kind of the predict method is that you'll call. So if we look here, you bring in your model input, you have your prediction engine here, and you will return. So you only create the prediction engine once in this case. And we'll come down here. So you create a new ML context. I haven't talked about the ML context yet because you only have to worry about it when you're using the APIs or later consuming the model. ML context is kind of the starting point for all ML.NET operations. It's the catalog of everything you can do with it. If you know DB context and entity framework, it's similar to that. So I'll create my new ML context. I will load in my model from wherever it is, and then I will create that prediction engine based on my model and the model input and output. So we'll get that back, and then we'll have our predict method here that we can just call, and it will do all that logic for us. If you were doing this, like creating an app from scratch for consuming a model, you would have to do all these steps on your own, which isn't too bad. It's just a few steps, but this at least makes it a little bit easier. So that's what's in the consume. And let's go into our program.cs. So what was actually created or generated in this console application? So we have this model input, which we saw the definition of earlier, and we're just going to call it sample data. And we're going to create a new instance of that and set the parameters here. Again, this is taken from our first row of data, but we can change it to whatever we want. So let's say this is this, and we'll put up the speed and maybe even bring up the temperature, just to try some data that we haven't tried before. And then what's going to happen is we're going to call that predict method on my sample data that I just defined, and it's going to return this prediction result. And so then I'm going to just print out to the console this stuff, which actually will be changed now. So if I actually wanted to match it, I would have to go through and do this. Hopefully I matched all of this. This is just to print it out to the console to make it easy to see what your input is when you're doing this. Oh, and toolware was a bunch of 9s. And then, so you use this prediction function, you got back this prediction result. Here, prediction result is going to be the output of the model. And if you remember, we defined that. We're going to return the prediction, so 0 or 1. So from there, let's add this as our startup project, set a startup project, and we're going to run this console application, which is going to use our model for this new prediction. And I don't know if it will open the console on this screen or this screen. So if it opens over here, I'll bring it over. Aha. Okay, so I don't know if I have to. Okay, so here you have, using model to make a single prediction. So comparing the actual machine failure with predicted machine failure. So here's all those inputs. So the actual machine, well, actually, I forgot to get rid of this one. This was the machine failure for the sample input that we had before. So we actually don't know what the machine failure was for this particular thing. I should have actually removed this one because this was for old model input. So let's pretend we don't know what the machine failure is. In this case, the predicted machine failure was 1, which makes sense because it was pretty worn down. We've used it for a long time. Whatever the machine was, the speed was really high and the temperature was really high. So we predicted, again, that this would be machine failure. And of course, I could go through and try out different ones, or like I wouldn't have to hard code this. I could take in all these from the console input, or sensors from the machine that would then give me the prediction. And if it was 1, I would probably set it up so that I had some sort of alert saying, hey, this machine is going to fail soon. So then that's where the predictive maintenance comes in. And yeah, so that was how you consume the model. Let me go next. I think this is just the summary. So no more knowledge checks that I can check to see if you all and Jamie were were paying attention. But yeah, so I guess from there, if there's any more questions.
Yeah, we do have a few questions, and keep them coming, folks that are still watching. So a couple questions. One is, I've been learning ML for about a year and I've only used Python. I know some basics of C#, but would you recommend me starting using C# or ML?
I guess he wants to answer for me. So the question is, do you recommend I use C# for machine learning? That, again, that's going to be kind of a personal preference. If you are, passionate about .NET and C# and that's the language that you want to learn, and you also want to do machine learning, then totally go for it. Like, use .NET for machine learning. You can also combine the two, right? Like, it would be awesome if you had that Python knowledge and you want to continue learning with Python to develop the models in Python and then consume them in .NET. So yeah, it's another one of those. It depends like kind of what you want to do with it. And there's definitely some areas right now where kind of Python-based frameworks have an advantage. For instance, our data prep story right now is something that we're working on, like data exploration and wrangling with .NET and ML.NET. And so sometimes it's helpful to, maybe you might find helpful doing Python and bring it over to .NET. So there's advantages to both. I mean, I'm on the .NET team, so of course I'm going to say try out ML.NET, see what you think. But again, we're not trying to pull people away from Python or anything. Happy to have you use both. And yeah.
Yeah, I think there's a good comment in the chat that says for folks using Python, you can also use F# in a lot of these cases as well.
Yeah, and that's something else that we're working on. We know, like right now, it's the way that ML.NET is with F#. It kind of just took the C# code and put it into F#. And so we're actually looking into making it a lot more idiomatic F#, which will hopefully help with that as well.
Awesome. Okay, great. So Chinmay from YouTube asks, is Predict Engine multi-threaded?
The prediction engine is not. So that's when you would want to use the prediction engine pool, because the prediction engine is not thread safe. Yeah, and if we have some documentation on it too, Louise, feel free to post that in the comments if needed.
Yes. Okay. So Jose from YouTube asks, how can we do a transfer learning in ML.NET for image classification? As in, how can we improve our model inserting new samples?
Okay, let me think about this. Okay, a few parts here. So the way that you do transfer learning right now is we only have transfer learning within our image classification API. So it's kind of, again, scenario focused. I want to do image classification and I can't use a pre-trained model because like my scenario or domain is more specific. So that's when you'd use the image classification API. And I believe we have tutorials on that. So again, maybe we can drop those in the chat for how you would actually build it. You can also use Model Builder for it. That uses the transfer learning too. How can we improve our models? So again, possibly adding more images per class could help, making sure that the images are relevant. If a lot of times with images, if you're doing, you want to make sure you get a lot of different angles, different lighting, and so on, that is going to mimic kind of the real world. Because if you only have kind of I don't know, I'm trying to think of a good example, like maybe dogs versus cats, right? Like if you only have like one type of breed of dog that you have, then that's not really going to help out much, because then if you have a different breed of dog, it won't know if it's a dog or a cat. So, or like if you only do an image of a dog from one angle, if you do it and you only have images, the model's only trained on images of the dog from one angle, like straight on, it won't know from the side that this is a dog. So adding in more angles, different types of lighting, relevant images, and so on, can help improve your model for sure. There might be, so we have a community member, John Wood, who does a lot of ML.NET, videos. So he may have one on image classification API. I wouldn't be surprised if he did. But yeah, we should have some documentation as well.
Yeah, we definitely have tons of documentation. We've also updated our .NET website. All of those links, documentation, videos, blogs, even some specialized GitHub samples for this specific workshop can all be found at the aka.ms/ml-net-resources link here. And so we do have all of those links in there as well. So please refer to that. We have one more question. And it may be a little general, but that's okay. So what is the ML ops ecosystem for ML.NET? Are there some possibilities to help me deploy and manage my models?
That's a great question. So that's something else that we're currently working on. ML ops, and I briefly mentioned it before, is kind of like DevOps for machine learning. It's, how do you automate the workflow? How do you keep track of model versions? How do you integrate it with CI/CD? So that's something that we're currently kind of working on. And we recently did this. We talked to a lot of customers to start planning it out. So yeah, that's kind of where we're at right now. Like for model deployment, like with Model Builder, we have those project templates. We also have a few docs on the different ways that you can deploy it. So deploying, if you know how to deploy a .NET application, that part shouldn't be an issue, but the managing models part is definitely something that we're currently working on, both like in tooling and Model Builder. We actually have some designs right now that we're starting to test for the different versions of models and different data sets, as well as making it really easy to integrate with the ICD. So yeah, so it's kind of in the works right now, is my answer. But look, keep an eye out, because we'll have it. And the other thing I was going to mention is ML ops is kind of a newer thing because of this issue of deploying and productionizing machine learning models, because it has been so difficult in the past. So it's kind of something that every framework and tool is kind of trying to figure out right now. So that's kind of fun, because we're kind of in the helping pioneer that.
Yeah, absolutely. So stay tuned, follow those repos, follow the documentation for these updates. Okay, one more question. So David from YouTube asks, how often should you retrain your model as your data changes over time? Is there a metric for this in the library?
This is a great question. I'm so sorry for this answer, but it depends. So some people have it on a schedule. Like it's going to depend on your scenario. Like some people will have it on a schedule where they retrain like on the same pipeline every week. And then every month they will retrain with AutoML to see if they have a new pipeline serves it better. So if you're like constantly getting in new data that you want to use for training, or your scenario or domain might be kind of, it can shift or change depending on changing data over time, then you'll probably want to train more often. But if it's kind of like stagnant data, where I'm trying to think of an example, like if you are categorizing articles on a website and you're not getting any more articles, then you probably won't need to retrain that model. You just retrain it one you already have, and that model will work forever and always. Like if you're not going to have any more categories and such. But yeah, and somebody, I see someone mentioned in the chat, like, is there functionality to detect drift over time with your deployed models? So that's going to be part of our MLOps story, and something that we're definitely aware of. So it's called data drift. So kind of what I talked about, if your data is kind of changing over time and going to affect the performance of your model, we want to make sure. And I believe Azure ML has some sort of data drift feature. If you all have heard of Azure ML or used it, but it's definitely something that we'll keep in mind with our MLOps stuff. As David said, like giving guidance for when to retrain. So we'll give options, like here's probably when you want to retrain this often, and so on. We can give kind of general guidance, but it's going to be specific to your scenario.
I see. That makes sense. Okay, so another question we have is the way that you tested the quality of the model seems limited. How can I do that better locally or without cloud?
The way that I tested the model seems limited.
Yeah, it says the way you tested the quality of the model seems limited. How can I do that better locally with no cloud?
Well, I did that all locally with no cloud already. So everything that I did just now is locally.
Great.
But
we didn't access any Azure.
We didn't access any Azure. No, that was all done just locally on my PC, which is why it was, actually didn't take very long. It was 10 seconds, but let me think. So I'm not exactly sure how to answer this question because I'm not sure I understand it, but you could, so there are, maybe I understand it this way. So there, in Model Builder in the UI, we only show like one evaluation metric, and there are other evaluation metrics you could see. One way you might be able to do this is if you're using Model Builder and then you get your pipeline, you could use that pipeline to retrain and evaluate in using the API, and then get different evaluation, get more evaluation metrics. Or you could train a model from scratch, and there's a lot of different evaluation metrics that you can see. So maybe you mean because we only had really one evaluation metric that we were using in Model Builder, that we could see that was pretty limiting, which in some cases there might be scenarios where you want to have a different optimizing metric. Like you don't want to use accuracy, you want to use something else. We are adding that functionality into Model Builder soon, where you can choose another metric for choosing the best model.
Okay. I see. Yeah, I think you answered that to the best of your ability there.
Yeah.
Sure. Okay. So what was the time spent from prediction start to prediction response? And is...
Well, I didn't measure it. We could try it again. Do you want me to run it again? Probably 10 seconds in this case, because again, my resources are being used for a lot of different things. But it will depend on, I'm so sorry for saying that so much, but it's true. Kind of the size of your model and the scenario. So if I was using an image classification model, that's going to take longer for prediction time or inference time than for this very simple one that I'm getting a 0 or 1 out of. It's only going through 12 columns and 12 features. So it was pretty simple, and only took 10 seconds probably, and if I wasn't streaming would take less.
Okay. Yeah, so how can folks kind of continue their learning with ML.NET and ML as a whole? I know we have some community stand-ups that you run, and we're continuing to add to learn modules.
Yeah, we have a ton of resources. I think we have a URL list for that, right? So I would say we have documentation. So if you're one that likes to follow tutorials step by step or dig into the API reference, that's one way to get started. If you'd rather just dig into code, our samples repo is a really great place to start. We have both C# and F# examples of split by task. So we have classification, regression, image classification, all of them, where you can just clone that and run it. And then dig into the code that way and start understanding the different pieces of code. If you like videos, again, we have a lot of community videos like John Wood. He has a great playlist with like 100 ML.NET videos from more intro stuff to more advanced. There's a few books out there if you like reading books. I don't have like a specific recommendation for one, but there are some out there. Like I said, Model Builder is a great way to start because you can like get the pipeline and built for you and then start to understand the pieces of it and get that auto-generated code and understand what everything does. And then, we have every other Wednesday, we do a community stand-up for machine learning and .NET. So that's also a great way to, if you have any questions, we do office hours quite a bit and have different, topics and stuff on there.
Great. Yeah. So join our ML community, hang out with our PMs who are building the product. Feel free to contribute your opinions and your actual code efforts. All of this information can be found at the resources link. We also have a brand new ML.NET page with all of these links and more linked right here below. And that was amazing, Bree. Thank you so much. I learned so much today. I hope everyone who has followed along did as well. We have lots of amazing features and updates coming to ML soon, as you heard. So make sure to stay tuned, follow those repos, and join us on our community stand-ups. And for those of you who are .NET developers, we have a huge, and a puppy. We have a big conference coming up on November 9th through the 11th called .NET Conf, and we will be talking about VS22 launch as well as the .NET 6 launch. So it's going to be really, really great. You're not going to want to miss it, and we're going to play that preview for you right now. Thank you so much, Bree. Thank you so much, everyone, for joining us. We hope to see you next time on Let's Learn .NET.
Thanks, everyone.
Save the date for .NET Conf 2021, November 9th through the 11th for the .NET 6 launch. .NET Conf is our annual free 3-day virtual developer event co-organized by the .NET community and Microsoft, sponsored by the .NET Foundation and our ecosystem partners. For 3 days, you'll learn from featured speakers from the community and .NET teams at Microsoft, talking about .NET 6, C#10, Azure, Visual Studio, and more. This is your chance to learn, ask questions live, and get inspired for your next software project. We've got wall-to-wall content for web, mobile, cloud, desktop, games, services, libraries, and a variety of platforms and devices, all with .NET. Everyone is going to learn something, no matter if you're just beginning or you're a seasoned engineer. Don't delay. Head to www.dotnetconf.net. That's .NETconf.net to learn more and tune in.